let's get started, guys. So we're going to, all right, folks, let's stop talking. We're putting 6.7 and 6.8 together. They're kind of all about the same thing. So we're going to talk about how we use coordinates with geometry. And there are three main tools that we're going to use. We've talked about them. We've talked about them before over the course of the semester. So three things that we're going to use to help us solve these kinds of problems. So when we're using coordinates, we usually have either we're given or we have a graph. We're given some points. So we'll call them x1, y1, and x2, y2. So one of the tools that we're going to use is slope. And the slope is going to help us figure out some things. So just a reminder, we usually say slope, we use the letter m. y2 minus y1 over x2 minus x1. Rise over run. And we use the slope to decide if and I'm going to say decide lines are parallel. How does the slope? If we find the slope of two lines or two segments, how does the slope tell us if they're parallel? It's the same. If the slopes are the same. So if we have a shape that we think is a parallelogram, we need to decide if the opposite sides are parallel. We can find the slopes of those opposite sides. We can decide if those segments are perpendicular. How do slopes help us decide if two segments or two lines are perpendicular? What is it? You were right. Opposite reciprocal. So the slopes opposite reciprocal means we flip the fraction and change the sign. And then if they're neither, so they're not parallel, they're not perpendicular, we don't have anything special that relates the two slopes. So slope is going to help us decide whether segments are parallel or whether segments are perpendicular. So, and we've talked a lot about that with our special quadrilaterals. We will also use the distance formula. And if we have 2 points, our distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. And we'll use the distance to compare lengths. So if we have the points that connect some sides, and with the points, we link up the points to make a quadrilateral, we can see if their sides are the same length by calculating the distance between the points. So we'll use the distance formula to compare lengths, and we'll use our midpoint formula. x1 plus x2 divided by 2, y1 plus y2 divided by 2. So that finds the midpoint between these 2 points. And we'll use the midpoint formula to find midpoints, bisectors, anything that has to do with finding the middle of a segment. That's how we'll find we'll find the middle of a segment using a midpoint. If we want to find the bisector of a segment, we have to find the midpoint. All right. So those are our tools. Those are the main tools that we're going to use with coordinates. What I want to do is show you an example, a couple of examples of how we might use these things to help us decide something about a shape. If it's graphed, if we have the graph, we have the coordinates. So let me get a grid page. There we go. All right. So let's say we have a quadrilateral. And we're going to call it QUAB, quad. Then we'll use our graph table. So the point Q is the point 1,4. The point U is the point 7,8. Point A is 9,5. And D is 3,1. We want to classify. And when we classify a quadrilateral, what they're asking us, is it a parallelogram? Is it a rhombus? Is it a rectangle? Is it a square? So let's plot this. So let me draw a set of axes here. Yes? Yeah, this would be a good one to put on your graph paper. So there's point Q, 1,4. I'm going to go over 1, 2, 3. There's a point U. I'm just plotting these points, A, and finally D is over 3 up 1. And there's point D. And I'm going to connect those together. All right, so there's our quadrilateral. What does it look like it could be? Maybe a rectangle? Looks like it could be a rectangle. So we want to figure that out. It could be. We don't know for sure. So what could we do to decide if it's a rectangle?
Check the slope.
The slopes of the opposite sides.
Yeah.
That would tell us whether or not they were
parallel or not.
parallel. And what would the slopes tell us about two sides that were next to each other? Whether or not this is a 90-degree angle, right? If these are perpendicular, then those angles would be 90 degrees. So that's going to be a good tool to use. Is there another way we could do it? Find the lengths of the sides. See if they're all the same. Is there another way we could do it? See if the diagonals are congruent. Decide if the diagonals are congruent using the lengths. So lots of ways. The slopes, I think, are the easiest. So let's calculate some slopes. So I'll do the slope between Q, which is 1,4, and U, which is 7,8. So I'm going to say M, and I suggest you always label your points, x1, y1, x2, y2. You could do it on your graph here. So y2 minus y1, 8 minus 4, over x2 minus x1, 7 minus 1. The minus 4 is 4, the minus 1 is 6, and I can reduce that to 2/3. All right, so that slope is 2/3. Now I want everybody to find the slope between D and A. D is 3.1 and A is 9.5. All right, so everybody on your sheets, you go through the calculation. I did an example. Everybody go through the calculation and figure out what that slope is. So put the points up there, calculate that slope. Get it? Saw some good answers there. So what do we get? This comes out to 2/3 also. So what does that tell us about these two sides? Not congruent, but parallel. Their slopes are the same, so they're parallel. Now let's calculate the slope between U and A. So that's going to be the point 7.8 and the point 9.5. All right, so you guys calculate that one, yes? Not for this one. Here we're just finding slopes. So we're just finding the slope of this segment between those 2 points. The slope between those two segments, those 2 points, yes. So shouldn't matter which order you do it in. You should all get the same. All right, what do we get here? Negative what? Negative 3/2. So I'm going to do 5 minus 8 here over 9 minus 7. So we get negative 3/2. Nice calculating slopes. So what does that tell us about UA and these two? They're perpendicular. So these two are parallel, and that's perpendicular. So what does that tell us about these angles? They're 90 degrees. So I could put some arrows here and say those are parallel, those are parallel. That's 90 degrees. That's 90 degrees. And let's finish up by finding the slope between Q and D. So that's going to be the 0.14 and the 0.31. So we'll calculate that. Between Q and D. So we're finding the slope of this side. Label my point x1, y1, x2, y2, and my slope is 1 minus 4 over 3 minus 1, and I get negative 3 halves. So what does that tell us about this shape? It is a rectangle, just like we thought. We figured out that these two sides were parallel and that all of these angles were 90 degrees. So this is a rectangle, and I'm going to put here, yes. It's a parallelogram with 4 90-degree angles. All right, questions there? All right, let's look at another slightly different kind of example where we're going to use a different formula. All right, and this can go on your graph paper as well. So for this one, we're going to start with a triangle ABC. All right, folks, let's stop talking. I know it's exciting, calculating slopes. Let's stop talking. All right, we want to find the endpoints of the mid-segment. So let's sketch a graph here with my axes. So we have point B here at 0, 0. We have point A at 2, 2, 6. There's point A. And 9, 0. So there is our triangle. So let me connect those points. A little skinnier, color. All right, so there's our triangle. And this is point C. How do we find the mid-segment? Where is the mid-segment? Do we remember? Midpoint of triangle, what part of the triangle? The legs, the sides, right? The mid-segment connects the midpoints of two sides. So we need the midpoints of two sides. So let's find the midpoint of segment AC. Let's find the midpoint of that one and segment, or sorry, AC and AB. So I'm just going to do them in columns here, find the midpoints of those sides. So the midpoints between AC. So that point is between 2, 6 and 9, 0. So I'm going to use the midpoint formula, label my points, x1, y1, x2, y2, and plug these numbers into our midpoint formula. X1 plus x2, so that's 2 plus 9 divided by 2, comma 6 plus 0 divided by 2. 2 plus 9 is 11, divided by 2 is 5.5, comma 6 plus 0 is 6, divided by 2 is 3. So the midpoint of that segment is over 1, 2, 3, 4, 5 and a half, up 1, 2, 3. Right there. And then for segment AB, we have the point 2, 6 and the point 0, 0. So that should be, that one's easy. You don't have to do much arithmetic. So our midpoint is going to be the point 2 plus 0 divided by 2 and 6 plus 0 divided by 2. So I get 2 plus 0 is 2, divided by 2 is 1. 6 plus 0 is 6, divided by 2 is 3. So I go over 1, up 1, 2, 3. And, whoops, I'm going to do that. It's supposed to be red. There we go. And there's our mid-segment. Now what if the problem had asked us then to show that the mid-segments, what do we know about the mid-segment? How does it compare to this side? Half the length, right? So what if the problem asked us to show that the mid-segment was half the length of the base? What would we have to do?
You got to know the length.
Know the length, and how could we find the length?
The
For this one, it would be fairly easy because we could count squares, right? So how long is this one? 9. How long is this one? 1, 2, 3, 4.5. Is 4.5 half of 9? Yeah. And what else do we know about the mid-segment compared to this base? It is parallel. What if the question asks us to show that it was parallel to the base? Find the slopes. And the slopes, if it's parallel, would have to be equal. The same. So the question might ask you to find the mid-segment and then find some other things about it. But we have all the tools to do that. Okay, questions on those ones we did on the graph papers? They're not difficult. Sometimes working with those formulas, it just gets it's a little tedious. I get that. All right, so let's look at some other things that we do with coordinates in geometry. Sometimes we'll work with problems where they don't give us numbers for our coordinates. They just give us variables. And I always say the best math is where there aren't any numbers. They're just letters. So let's say we want to find the distance between the points PQ and RS. They don't give us any numbers. They just say, here's our points. If we know what P and Q are, R and S, we could plug in numbers, but we don't know those. Well, we don't let this bother us. We know how to use the distance formula. So I'm just going to label the points just like before. x1, y1, x2, y2, and plug those into the distance formula. Distance equals the square root. x2 minus x1 squared plus y2 minus y1 squared. And that's all we can do. That's the distance between those points. Yes. So we that's all we would write. We can find the slope. Slope equals, what do we do for our slope? y2 minus y1, s minus q, over x2 minus x1, r minus p. All right, guys. That's what we would write for the slope. Unless we knew what these were, that's all we could write. So sometimes we end up working with problems like this. What if the problem asks us to find the midpoint between 0, 0, between, and 2p, 2q. I'm going to do just like we did before. x1, y1, x2, y2, and plug into our midpoint formula. The midpoint is x1 plus x2, and y1 plus y2 divided by 2. And what is 2p divided by 2? P. What's 2q divided by 2? Q. So the midpoint between 0, 0 and 2p, 2q would be the point PQ. Whatever that happens to be. All right, questions there? Okay. Want to look at a couple more quick examples, and then we'll be done. All right. Sometimes we have to figure out some information about coordinates without using numbers. So I want to look at an example like that. So here's my shape. I have this graph of this shape, and we know that this is a parallelogram. And we know that this point D is 0, 0. We know that E is at the point C, B, and F, we don't know the coordinates of that point. Question mark, and this is the point, G is the point A0. And we want to find missing coordinates. So for this kind of problem, what the question is asking us is how far over? And left and right is the x or the y in our coordinates. Is left and right the first one or the second one? X. First one, right? Going alphabetical order, X and Y. So how far over is the first point, and how far up? So that's really the question we're trying to answer here. How far over is that point? How far up is that point? Well, for this one, since it's a parallelogram, let's start with the easy one. How far up is point E? For up, how far up is it? B. It's the second letter, right? If this is a parallelogram, how far up does point F have to be? B. It has to be the same, right? So that point, this would have to be B. So that one's easy. Because it's a parallelogram, it's the same height, same distance up. So I go up B units to get here. All right, now what I'm going to do to figure out how far over is if I draw this line straight down, how far over have I gone to go from 0, 0 to here? C. That distance is C. If this is a parallelogram, if I drop this down here, how far over would I have to go from this point to get to there? The same distance, right? Very good. C. If I've already gone over A units here, and I go C more, how would I write that? A plus C, right? If this is 10 and this is 5, I go over a total of 15. To get those, I add those together. So that whole distance would be A plus C. how far I've gone over. So the coordinate F is at the point A plus C, comma, B. How far over? A plus C. How far up? B. We go over A to get here, another C, and then I go up B. All right, questions there? All right, one last example and then we're done. So I'm going to sketch or graph a triangle here. And we're going to say that A is at the point 0, 0. B is at the point 2A, 0. And C is at the point question mark B. And I'm going to draw another segment here. And we're going to say that CD is the perpendicular bisector of AB. And we want to find the missing coordinate. All right, so the problem tells us this is the perpendicular bisector. So what does it do to this segment? Splits it in half. How long is this segment? 2A units. So how long is each half? A, right? Half of 2A is A. So this has to be A, and this has to be A. So how far over are we going to get to this point? A. That has to be A. So C is the point A, comma, B. So we know the coordinates of that vertex of the triangle. All right, questions? Questions there? Another one like that? Sure.
Good. Good luck.
We'll do this, we'll do a little different kind of example here. So I'm going to say that A is 0, 0. C is question mark, and B is 2, 3. And I'm going to say that triangle ABC is isosceles. So we're saying that AB is congruent to BC. And we want to find C. We want to find point C. One of the coordinates is really easy. How far up is it? 0, right? So this one has to be 0. How are we going to find how far over? Well, we could use the distance formula, right? Calculate the length of this side, calculate the length of that side. But let's try to be smart. Let's save ourselves some work. What do you think? AB is going to BC. So if we were going to use that, then we could use a distance formula. But I want to save some work. Yeah. On an isosceles triangle, that's a very good idea. That's exactly what I was thinking. If I drop that perpendicular bisector down, what does the perpendicular bisector do to the base of the isosceles triangle? Cuts it in half. So how far over have I gone to get here? 2. If this base is bisected, how far over do I have to get? What does that make that length?
4.
That makes that length 2, and it makes a total 4. So that would be 4, 0. Similar kind of idea. All right, nice catch. All right. Okay, so homework. We have 2 pieces because we talked about 2 sections. All right, and don't forget that the mid-chapter quiz due Friday.